Alright, so section 10.1 is on exponential functions. So if you guys remember when we did our M&M activity, we had an exponential function. So it started out with a really high value, and then it slowly like halved. So that's what we're going to be talking about. It's not always going to halve, but it could go down by a different amount. Okay, so the function y equals b to the x, where b is a constant greater than 0, and the exponent x is an independent variable. So it's like if I had a t-table, that's the thing I'm selecting. B is called the base. So let f of x equal 2 to the x and evaluate the following. So if I have f of 3, that means 2 to the 3. 2 to the 3 is 2 times 2 times 2, so 8. Okay, this next one is going to be 2 to the 3 over 2. Do you guys remember what fractional exponents mean? So what does 3 over 2 mean as a power? You've all forgotten. The top number is your power. The bottom number is your root. So you're going to have 2 to the third under a square root. You can put a little 2 there, but a square root is already within 2, right? So it's going to be the square root of 8, which we simplify as 2 root 2. Okay, could somebody do square root of 8 on their calculator so we can see what that is as a decimal? 2.8 is 2.82. Yeah, 2.82. So we'll do approximately. Okay, so if I have f to the negative, or if I have 2 to the negative 3 over 2, do you guys remember what a negative exponent means? 1 over. So I have 1 over the square root of 8. So let me write out the middle step in there. Square root of 8, remember that was from the 2 to the third under a square root. So 1 over the square root of 8. You could rationalize that if you want, like it would be 1 over 2 square root of 2, and then you multiply by square root of 2 on the top and the bottom. So here you'd have square root of 2 times square root of 2, which is 2. So you'd have square root of 2 over 4. Or you can write it as a decimal, so in this case it'd be 0.35. And then f of pi, so we could have 2 to the pi. That's a number, so do 2 to the pi on your calculator. You get 8.82. Yeah, this symbol I'm doing here is approximately. I do that whenever I round, because it has more decimal points than that, but I rounded to 2 decimal places.
On number 3, if you left it as 1 over the square root of 8, would that be incorrect?
It would be okay. Technically, in Algebra 2, we still rationalize denominators, so we would probably have that. But later on, like in calculus, we don't even bother rationalizing denominators because there's so many other calculations you have to do, you know, so we just don't worry about that. So, all right, so let's see what the graph looks like. So 2 to the 0 is 1, 2 to the 1 is 2. So that means I have the point 0, 1. I have the point 1, 2. I have 1.5, 2.83, because that was 3 over 2. 1.5 is 3 over 2. And we did 2 to the 3 over 2 earlier. 2 to the 2 is 4. So 2 squared is 4. So it looks kind of like a line. But then if you try some more, like if I did 2 to the third, 2 to the third is 8, remember? So that shoots way up there. All right, but then we have 2 to the negative 1. 2 to the negative 1, what does that mean? What's that? Negative 1 means what? 1 is on top, 1 over 2. So I get negative 1, 1/2. Negative 1.5, that was the negative 3 over 2 that we just found. So 2 to the negative 3 over 2 was 0.35. So it's getting closer to the axis. 2 to the negative 2. What does that mean? 1 over 2 squared, right? So 1 over 4. And then 2 to the pi was way up there past 8, so like right here. Oops. All right, so we end up with this kind of curve. Really similar to our M&M activity, but now it's going up. Our M&M went down, right? Okay, notice there's a horizontal asymptote at y equals 0. If you think about it, 2 to the negative 500, is that negative? No, it's 1 over 2 to the 500. That's a positive number. It's just really, really, really tiny. Your calculator wouldn't even be able to compute it. It's so tiny. Let's say like overflow. All right, so it's getting closer and closer to 0, but it's never equaling 0. All right, so let's try it with 1/2 to the x. So if I have 1/2 to the x, okay, so I'm going to have 1/2 to the 0. Anything to the 0 is 1. So again, I have the point 0, 1. I have 1/2 to the 1, so that's 1/2. So you have 1, 1/2. I have 1.5, 0.35. I gave you a couple of values. So 1.5, 0.35. 1/2 to the 2 is 1/4. You see how this is relating to the other graph that we did? See how some of these numbers are the same? What's different about our x values, though? So what did we get 0.35 on the other chart? Negative 1.5, right? Okay, so let's try another thing. If I had 1, I got 1/2. On our other chart, if I had what value? I got 1/2. Negative 1. So see how it's just the opposite x value? All right, so if I have negative 1, that's 1/2 to the negative 1, which means I flip the whole base, so it becomes 2 over 1 to the 1, so I get 2. So negative 1 gives me 2. Negative 1.5 gives me 2.83. Negative 2 is going to give me 4. And pi gives me 0.11. So now it's going this way. It still has a horizontal asymptote at y equals 0. No vertical asymptotes at all. All right, this is like our M&M one. Only our M&M one started at like 100, remember? All right, so this is a graph of what we call exponential decay. So slowly, the y values are getting smaller and smaller. Okay, so exponential growth looks like this. Exponential decay looks like this. Both of our graphs went through the point 0, 1. Okay, and they were both in the form y equals b to the x, like some number raised to the x. But what's our hypothesis? So with growth, what do you guys think b has to be? So we use 2, but could it be other numbers like 3, 4? Yeah. When does it become decay? If it's a fraction. So if it's a fraction that's smaller than 1, right? So anything smaller than 1 is going to create the exponential decay. All right, so we're going to say for exponential decay, we're going to say where b is between 0 and 1. Okay, it can't be equal to 0. Think about it. If it was equal to 0, then you just have 0 to the x. It'd always be 0. That's not really a curved function. It's not an exponential function. And it can't be 1. Why can it not be 1? Yeah, then you just have 1 to the x, 1 to the second, 1 to the third. I mean, these are all going to be 1, right? So that's not creating that curved graph either. So b has to be between 0 and 1. Now think about it. Can it be negative? No. Because if we had a negative number, it does a really weird graph. Like think about if I had a negative number to the third, and then that same negative number to the fourth. Negative 2 to the third is negative 8, but negative 2 to the fourth is positive 16. So can you imagine what that graph would look like? The y value for one would be positive, the y value for the next would be negative, and it'd be flipping back and forth. And then who knows if I have like 3 over 2. That's really crazy. Okay, so we don't do with b values that are negative. We don't deal with those. Okay, so this next one, so exponential growth, this is where your b value is greater than 1. So it could be like 1.5. It could be a fraction, but it's a fraction that's bigger than 1. All right, horizontal asymptote. So it's a line that a graph function approaches as the value of x gets really large or really small. So find we've talked about that before. So we had exponential, or we had horizontal asymptotes at y equals 0 for both of those. Okay, so example 1. So find the exponential function f of x equals b to the x, whose graph is given. All right, so here's our function is going to look like f of x equals b to the x. Now we are going to talk about other functions that look like f of x equals some initial value like p and then b to the x. Okay, that gets a little confusing. We're going to talk about that in a little bit. But let's say it's just, the initial value is 1. So it's 1b to the x. Okay, well, an important point that I said we have is 0, 1. So that means if I plug in 0 for x, I'm going to get 1 for y. Okay, is that true? B to the 0 equals 1? Yes. Okay, let's use another point. So let's say I have this point right here. That looks like 1, 3. So if I plug in 1 for x, I should get 3 for y. So that means I have b to the 1 equals 3. That solves for b. So what's b? 3. So that means my function is, I'll use f of x since I used f of x. So f of x equals 3 to the x. That's my function. Okay. This looks pretty good because it's exponential growth. It's getting bigger. And our b value is more than 1. So I know that I'm doing this correctly. All right, so let's try this one. So again, I have 0, 1. Here's another point that I think is good. See how you have one crossing right at negative 1, 4. So let's use that. So negative 1, 4. So if I have the point negative 1, 4, that means when I plug into my function, b to the x equals y, I'm going to plug in negative 1 for x. I'm going to get 4 for y. What does that mean when I have b to the negative 1? B equals what? 1/4, right? How'd you do that, Gabby?
Because it's negative, so it's a fraction.
So it's 1 over b equals 4. You can cross multiply if you want. You can think of that as being over 1, and you can cross multiply. So you get 4b equals 1, so b equals 1/4. So that means your function is f of x equals 1/4 all raised to the x. Notice I put the 1/4 in parentheses, so you can tell all of it's being raised to the x. Okay. Yes, Mary.
How do you know that you use that point?
You could use any point. It doesn't matter. Usually if you can find where x equals 1 or x equals negative 1, if there's a point that lines up there, those are the best. But you could have used negative 2. See how it crosses at 16? Mm-hmm. Yep. So if I did negative 2, you would get b to the negative 2 equals 16. So that's 1 over b squared equals 16. And the only thing that gets confusing on this one is you would end up with b squared equals 1 over 16. So you'd get b equals plus or minus 1/4. But what did I tell you about the b values? That makes you know it's the 1/4. can't have negatives, right? Do you guys remember? So I said you can't have a negative value because then it would oscillate. It would like jump from positive to negative to positive to negative. All right, so it would have to be the positive one. All right, so you could have used any value there. All right, so these ones are a little bit harder. Notice how these ones don't go through 0, 1. So it doesn't go through the point 0, 1. Okay, what that means is we have some kind of number out front that we're multiplying by. So that means that we have f of x equals p times a to the x. You can put a little multiplication sign if you want. Now, only the a is being raised to the x value. In the end, you're just multiplying by p. Okay, so we always, on these ones, we always want to know where it's crossing. So we need to know the y-intercept. So in this case, we have the point 0, 5. So that's going to be the first point we deal with. So if I have 0, 5, that means when I plug into this function, y equals p times a to the x, I'm going to get 5 for y, 0 for x. What's a to the 0? 1. So I get 5 equals p. So already I found what p is. Now I need to find what a is. So now we pick another point. So what's another good point to pick? Looks like none of them are really crossing very evenly. I see one that crosses. Do you guys see it? -1, 10. Do you guys see that one? See how the other ones aren't crossing on like nice whole numbers? So let's try that. So -1, 10. So I have y equals p times a to the x, and I've already solved for p, so I know it's 5. So I'm going to plug that in. I'm going to plug in -1 for x and 10 for y. So I'm going to get 10 equals 5 times a to the -1. A to the -1 means 1 over a. So I have 5 times 1 over a, which is 5 over a. I'm going to multiply my a over. Oops. So if I multiply this a over to the other side, I get 10a equals 5. Or you can think of it as cross multiplication. So I get a equals 1/2, 5 over 10. So your final function is f of x equals, we found p was 5, we found a was 1/2 raised to the x. Okay, that's your answer. Now a lot of people mess this up. Were some of you guys thinking that you should have 2.5 to the x, like 5 times 1/2, you should multiply them? You don't multiply them because you're going to follow the order of operations. Does that make sense?
Yeah.
So you have to do the exponent before you can multiply. Yeah, Taylor? Why did I put the 5 what? Because it says your function should look like a number times another number raised to the x. And we found p was 5, and then a was this. Okay, you guys try part B. So try part B. All right, so I told you the first point that's most important is to look for the y-intercept, which is 6. So if I have the point 0, 6, and I'm plugging into y equals p times a to the x, I have 6 equals p times a to the 0. A to the 0 is 1, so you get 6 equals p. Okay, so we found p. Then you need to find a. Okay, p is what we call the initial value. Does that make sense? So it's where it's crossing the axis. Kind of like our M&M thing when our initial value was 100, we start with 100 M&Ms. All right, so now this one. I'm guessing you guys used 1, 4 probably. Looks like a good one. So you should have y equals 6 times a to the x. So you get 4 equals 6 times a to the 1. So you get 6 times a equals 4. So 4 over 6 equals a. And you guys told me you got 2/3, so you reduced it down. So you should have f of x equals 6 times 2/3 to the x. And once again, don't multiply your 6 times 2/3. Because think about if you're doing a t-table, you'd have to plug in numbers for x. So you'd raise the 2/3 to the x, and then you'd multiply by 6. Okay, so you have to follow your order of operations. So you're leaving the x as a power, and you can't multiply these together. Allie, you look confused. Do you want to try a couple numbers?
Well, because I plugged in -1, and I got 2/3, but I didn't get the.
You didn't get the 6. Okay, the 6 should be the first thing you get, because you should try 0, 6 first.
I got that. I don't know.
All right, so 3a. So tell whether this is growth or decay, then find 2 points on the graph. So growth or decay? Decay, why? It's less than 1, right? So 3/4 is less than 1. So it's decay. All right, and then we're going to find 2 points. The easiest numbers to plug in for x are 0 and 1. So if I plug in 0 for x, so let's do like a little t-table. If I plug in 0 for x, I get 8 times 3/4 to the 0. Anything to the 0 power is 1, but that's not counting that 8, right? Only the 3/4 was being raised to the 0. So it's 8 times 1, which is 8. All right, then plug in 1. So I have 8 times 3/4 to the 1. So I get 8 times 3/4. So the 8 and the 4 reduce down to 2. 2 times 3 is 6. Okay, so that means our 2 points that we found are 0, 8 and 1, 6. This last one. Oh, no. Okay, so in the next one, so g of x equals 10 times 1.05 to the x. So what's this? Yeah, this is growth. Because the 1.05 is more than 1. All right, and Gabby says she plugged in 0 and got 10. Because you'd have 10 times 1.05 to the 0, so it's just 10. If you plug in 1, you get 10 times 1.05 to the 1, which is 10.5. So our 2 points are 0, 10, and 1, 10.5. Okay, next up. Okay, so you can model growth or decay by a constant percent increase or decrease with the following formulas. So if it's a percent increase, you're going to do 1 plus r. So like if I was adding 5% each time, that would be 1.05, right? 5% is 0.05. Do you guys understand this? If I'm adding 20%, it'd be 1.2, right? So each time you'd be adding another 20%. All right, percent decay is going to be 1 minus r. So if I'm decaying by 15%, it's 1 minus 0.15. So it'd be 0.85. So you're getting 85% of what you have each time. All right, so Kendall invests $5,000 in an account that pays 6.25 interest per year. How much money will she have in her account in 10 years? Okay, P is what we call our principal amount, or the initial amount. R is the rate of increase or decrease. So in this case, this is our R. And T is the time. Okay, so my different values I have are P equals 5,000. I have my rate is 6.25, but I don't write 6.25 in math class. What do I write?
0.0625.
Yeah, close. 0.0625, right? Or are you saying 0.0?
Yes.
All right, and then time is 10. Sure.
I understood what I did, but
All right, so our amount after 10 years. So we notate that by A of 10, just like f of x, you know, f of 5 is f parentheses 5. It's not f times 5. A lot of people think this is 10a. This is just saying the amount after 10 years. So your amount after 10 years is your principal amount times 1 plus r raised to the t. So I'm using this formula right here. So I'm going to plug it in. So I have 1.0625 raised to the 10. I always have to do my order of operations, right? So I did my parentheses first and got 1.0625, and then I raised it to the 10. I got 1.8335. Now, Mr. Syrick will tell you, you guys do things like this in pre-calc, and people that round too soon get answers that are off by like $20. It's not going to be off by like 2 cents. It's going to be off by a lot. So even though I wrote 1.8335 there, I'm keeping that number in my calculator. So now I'm taking that answer, do you guys know how to do that? And multiplying by 5,000. So you get 9167, and now I round at the very end. So 0.68. And that's your answer. Okay, a city population, which was initially 16,000, has been dropping at a rate of 3% per year. Okay, so is this growth or decay? Decay, so we're going to use the second formula. So my population, or my initial amount, was 16,000. I've been dropping at a rate of 3% per year, so my rate is 0.03. I'm finding after 20 years what the population will be. So I wrote some little information at the beginning so I know what I have. So my amount after 20 years, I started with 16,000. I have 1 minus 0.03. I'm raising it to the 20. So notice how the 1 minus 0.03 is 0.97. That means each year you have 97% of what you had the year before. Each time you're multiplying by 0.97. Okay, so I have 0.97. I'm going to raise it to 20. So I had 0.54379. Again, that's rounded. I'm going to keep that number in my calculator. I'm going to multiply by 16,000. Okay, this isn't money. This is a population. So what would you say for this? Yeah, we don't have like 0.71 people. So we're going to say 8,700 people. All right, you guys try 3 and 4. Try 3 and 4. Well, at least I haven't taken attendance.
It's Jenny. I just realized I forgot to take attendance. So I'm missing Kendall, obviously, and then Sarah and Dee. And then I'm missing Kern, too.
Oh, it's been recording. Nice. All right. So I guess it was recording that whole time I was taking attendance. So you guys get the answers for 3 and 4?